Erlang today. If you're seeing this after the live, you should be able to skip ahead and see when I actually start because sometimes I start a little bit slow. I'll probably try to add a chapter for it in YouTube or whatever. How does this work? I was out all day today, so it was a really rough day, like for no reason either. Like some of my days for work, I don't get any sleep, I struggle a little bit, and it's really hard to get to work, but then once I get started, everything's okay. But then, like, today, I had a lot of sleep, I just chilled yesterday, and yet when I woke up, I was just like miserable, cranky, just couldn't get like things done. I was just like almost angry for no reason. Everything was just wrong. And then I went out with my girlfriend. I snapped at her a couple of times, which I never do. So that was kind of like weird. I think I'm still like residual whatever it is, but I took a shower. I changed out of my outside clothes. Sorry for how I look. Um but I really want to get a little bit of Erlang programming in here. I saw this video by the Primagen, and it was about Discord and Slack and how much Slack charges people for just the chat server. I was like, yeah, like, maybe I should just build a chat server in Erlang. Not like I really want to like think that I'm going to replace Discord or even make something that's a competitor, but it may be just an interesting sort of like example thing to build with a language. Try to get a chat server going. Just really basic features. That may be something that I work towards as I start learning Erlang, or maybe just do it in Elixir. We'll see what happens. In the previous, there's an Erlang playlist that I made in YouTube. So in the previous, we were using this in the previous videos. We went over stuff. We're using this book, Learn You Some Erlang for Great Good. Don't know if you can see that. Yeah, it's kind of light. It's a book that's open source. They have like a print version you can buy and get by Fred Hébert. I guess maybe like a French person. Um, Joe Armstrong, isn't that one of the guys that made Erlang? So that's pretty cool. I looked at the Erlang site itself and it's okay, but I don't think it's the easiest way to learn the language. Um, so we're just gonna stick with this for now. It is a long book. It's like actually pretty surprising how much you get out of this. Maybe it's not that long. It just seems long. So what did we cover already? We covered the shell, like REPL and the shell. I don't even remember it. This I remember, all the data types that we can use. We kind of stopped here. Then we had another day where we did bit syntax, and that's such a pain. It's basically the same thing as in Elixir, so it's just something I never really liked. This part of it, I hate when I have to do it. Um, so hate these chatbots. Maybe I should review it. Even it's like the thing you don't want to do is the thing you should do because it obviously means there's something bothering you about it. So how about we take a look again? We'll just bring up the runtime, the REPL. I think I often start with a little bit of review on what I learned. Let's see if we remember how to make a list comprehension. So we have the thing we're outputting, right? What the list is. And then we have a generator here. The generator needs to have the variable somewhere, like that you're going to use later. And we'll just have 1, 2, 3, 4, 5, 6. And this is just like the dumbest list comprehension you can make. It's basically like repeat the list. And if I multiply by 2, then I get, you can see what it does. And I can put conditions in here. N is greater than. Actually, remember the less than or equal to. You want to do this, but it's actually equal less than. Let's say equal or less than 3. So now you can see here that it only, whoa. Right. So it's going to do 1, 2, 3, and then it's going to double it. So you get 2, 4, 6. You see how that works? We can put this inside of a list if we wanted to, I'm guessing. And that's kind of lame, right? But you could. But more likely you would put it inside of a tuple. A single tuple by itself is kind of boring. So maybe you add like another list. It repeats it 3 times because each one is combining with the second list to make a combination. But we only print the n, so it doesn't. We don't see it. So let's fix that and print m. Now you can see it's 2, 1, 2, 2, 2, 3, 4, 1, 4, 2, 4, 3, 6, 1, 6, 2, 6, 3, right? So I think we proved to ourselves that we still remember list comprehensions. So what else do we got? What was after list comprehensions? Yeah, that's where we are with bit syntax. So let's take a look again here. So if we do 16 hash, that means that we're giving it a 16-bit number, right? Base 16. Put the binary values of on 24. No, where does it say the hash? I think we might have learned that when we learned about numbers. Let's see here. No? I think so. So if we have 2, this is 4, right? Yeah, that's base 2. We get a 4 there. Base 10, obviously, this would be a 100, right? And base 16, this would be a 16. Or 15, sorry. And 255 is basically all the bits on. So that's what the hash means. So let's go back to bit syntax. So here we are making a 16-bit reference to F09829. This is its equivalent in decimal. And then we're saying put that inside of put that inside of a string. Is that what it's called? I don't even pay attention. Bit syntax encloses binary data between these two angle brackets. So maybe I should just call it bit syntax. So here we're putting it inside of the angle brackets. Interesting. But we want to specifically say put it in 24 bits of space. So if we only had 16 bits of space, or let's say we only have 1 bit of space, then it only shows 1. Probably because 9, because binary 9 is 488. Whoops, that's 9, right? So you can see the first digit on the right is a 1. So when I break this out, it's taking the first digit on the right. The 9 here in 29 is going to be a 1 here. And so if I make it an 8, like this, then it should be a 0 on the rightmost digit. So let's try turning this number into 28. And this should give us 0. Yeah, there we go. It's saying 0 and 1 bit. So we understand what's going on here, I think. How's everyone doing, by the way? And if I put this in 1000 bits of space, I get this. I think it's going to put it all to the right side. So watch, if I make this 30, yeah, it kind of pushes stuff to the right. You see all of these are zeros. Let me do 31, 32, and now this became a 0. And it'll stay a 0 as I continue to push it until the second number becomes a 0 at what, 47 or so? Yeah. Do you guys do this too when you're learning something like something simple like this, but it's like, well, do I really understand it? How can I make sure? And I remember yesterday I was getting so confused by how many bits each of these things take, right? I don't know why I get so caught up in this. So in hexadecimal, if you want an F, right, that's basically 15. In binary, that would be like that's 8. So if I add one more 0, that's 16, right? So I don't need this many. I only need 4. 1, 2, 3. There we go. So this is 15. And this is equal to 16 hash F. True. So you need 4 bits for each of these hexadecimal numbers or digits. So that means 8 bits for each of these, and that means 8 times 3 because you have 3 pairs of this. So each color takes up 8 bits, right? Okay. So maybe I should write this down. What do you think? Like, it's something that is so obvious to people, right? But from some reason, it just really confuses me. all these names. So 16 hyphen 16 hash f, which is one hexadecimal number, is equal to binary 1111. Right? So this means what is, I'm guessing that hash is the byte. No, I'll just do it like this. Each hex digit, I don't even know if that's the right word. Each hex digit needs 4 bits nibble, or just 4 encoding. You guys are so quiet. Are you chatting? Where are you guys? Let me see here. I want to make sure I'm not, chat's not broken or something. We turn off speaker. Okay. Well, I'm guessing it's working. So, where was I? Right, so here I was saying that we need one of these. So therefore, we can say like each color is 16. We can say even more. Red is equal to 16, and we can give it something like F0, which was in our case here. And we had green, red, green, blue, right? Green is equal to 16 9A. And then blue is equal to 16 29. And color is equal to red, green, blue, right? In 24 bits of space, I'm guessing. Maybe that's not the way to do it. Maybe we have to say maybe this is not just for blue. Let's try this and see if this works. I'll copy this and then put it inside of Earl. Yeah, I didn't like this here. Oh, color should just be the numbers here. I mean, it's correct though, isn't it? Because hyphen 16 F0 is 240. So this string here is correct. All right. Color 24. This is saying it's 24. So what is the difference between color like this? Ah, why doesn't it like this? Um, because I already made color. I didn't make color a hexadecimal number. That's my problem. How did we clear stuff? Was it like this? Yeah, that's how we clear stuff. So if we do color is equal to 16 F09A29 period, and then we make a pixel out of it. We don't use anything. It doesn't know how big the space should be. Right, we were doing this earlier, right? Like, yeah, so now pixel is fine. So when you put something in here, what if I gave it like an extra number? What happens? Ah, it adds the one at the end. So each one can have its own number. I see. So this became 3 bytes. It looks like this syntax is always going to print out in 8 bits. What is called bit syntax seems to always output in list of 8 bits. Probably because that's how it's going to be a string mapped to like ASCII characters. And this doesn't work. We just have to do this. Which basically probably is the equivalent of, here, let's go back. This is probably, oops, I want this. All right, so now if I do pixel is equal to red, I'll just do this actually, red 8, green 8, blue 8. Ah, fuck. Oh, it's a single colon. There we go. Okay, this is starting to make sense to me. So if you don't put anything in here, it just defaults to 8, right? So we should say something like, um, this defaults to 8 bits. So basically, that's the same as saying um, red 8, green 8, blue 8 is equal to red, green, blue, right? That makes, now I get it. All right. So I want to say something like bit syntax defaults to 8 when you construct it. Also, bit syntax, I'll just say outputs. All right. Now we get it a little bit better. Anyone here like confused? All right. So this is a slow review here. The rest of it, I think, yeah, I get this. We can pattern match. We should move this whole section to bit syntax. Whoops. No, this section here. Just put it under. What happened to my whole fucking thing? I thought I copied this. What the hell? Here we go. Yeah, we can just keep that title. And now I'll get rid of this. I'm struggling today, guys. Like, sometimes when it's like this, it's got to go slower and hope things work. And then when we deconstruct a pixel, we can say how big we want it. So if we have like a bit syntax, we can deconstruct this way. I think I get it. So I'm gonna go on here. And then we have the bit shift operators. Let's put that in there. Um, some operators. Bit shift left, bit shift right, B and, B or, B XOR, and B not. To be or to be not. And then we learn some binary comprehensions. I'll review that next time. So today we're going to learn some modules. This isn't a long section, I think, so we should be able to get through it pretty quickly. Working with, so we're starting the module section. What are modules? Working with the interactive shell is often considered a vital part of using dynamic programming languages. It is useful to test all kinds of code and programs. Most of the basic data set types of Erlang were used without even needing to open a text editor or saving files. What's that sound? Why is the door opening and closing? Did you hear the door opening and closing? It's still opening and closing. Everything's okay? Everything's okay? Okay. Uh, you could drop your keyboard, go play ball outside, and call it a day. But you would be a terrible Erlang programmer if you stopped right there. I like the encouragement. Code needs to be saved somewhere to be used. This is what modules are for. Modules are a bunch of functions regrouped in a single file under a single name. Additionally, all functions in Erlang must be defined in modules. You already used modules perhaps without realizing it. The BIFs mentioned in the previous chapter, like what are BIFs? Built-in functions? I'm guessing. Like head or tail actually belong to the Erlang module, as well as all of the arithmetic, logic, and Boolean operators. BIFs from the Erlang module differ from other functions as they are automatically imported when you use Erlang. Every other function defined in a module you will ever use needs to be called with the form module function arguments. You can see for yourself. Module function arguments. So there's a module, Erlang, and what did they say that we learned? Like head, and we can pass in a list for head. Let's see if this is true. Yep. Um, and obviously we can, because it's in the Erlang module, we can remove the module name. But there is something called, oh, we did learn, they just told us about the element function, which you can take and it gives you the element back. No? Element? Oh, it takes a tuple and it returns which element. So it's index with 1. Out of range. Out of range. List sequence 1, 4. So this is a list generator, module, function, and we pass it in 2 parameters, the beginning of the list and the end of the list. And it generated a list for us. And if we took the head of this, we get 0. Okay. But we cannot call sequence without the module name because it's not in the Erlang module. We need to add list colon sequence. Here the sequence function from the list module was not automatically imported while element was. The error undefined shell command comes from the shell looking for a shell command like f, not being able to find it. There are some functions in the Erlang module which are not automatically imported, but they are not used too frequently. Interesting. So interesting that it looks like here they're saying every function in Erlang module is exported, but it seems like not all. Logically, you should put functions about similar things inside a single module. Common operations on lists are kept in the list module while functions to do input and output, such as writing to the terminal or in a file, are regrouped to the I/O module. One of the only modules you will encounter which doesn't respect that pattern is the aforementioned Erlang module that has functions which do math conversions, deal with multiprocessing, fiddle with the virtual machine's settings, etc. They have no point in common except being built-in functions, BIFs. You should avoid creating modules like Erlang and instead focus on clean logical separations. Makes sense. So we say modules, and then we can have like using, and we do list sequence 1 comma 4 in the format module name colon function args. Module declaration. So we're going to make one soon. When writing a module, you can declare two kinds of things, functions and attributes. Attributes are metadata describing the module itself, such as its name, the functions that should be visible to the outside world, the author of the code, and so on. This kind of metadata, this kind of metadata is useful because it gives hints to the compiler on how it should do its job, and also because it lets people retrieve useful information from the compiled code without having to consult the source. There are a large variety of module attributes currently used in Erlang code across the world. As a matter of fact, you can even declare your own attributes for whatever you please. There are some predefined attributes that will appear more frequently than others in your code. All module attributes follow the form minus or hyphen name parentheses attribute close parentheses. Only one of them is necessary for your module to be compilable. Module name. Seems like we should add this. Module hyphen module name. This is always the first attribute and statement of a file, and for good reason. It's the name of the current module where name is an atom. So it should be lowercase then, right? Like this would be name. So it would be lowercase. Atoms are in lowercase or in quotes. It's time to code already. Our first module will be very simple and useless, just like I like it. Open your text editor and type in the following code. Save it under useless.url. Module hyphen module, and we put in useless. Done. So, oh, right. Useless.url. We have useless.url here. We're good. This line of text is a valid module, really. Of course, it's useless without functions. Let's first decide what functions will be exported from our useless module. To do this, we'll use another attribute, export. So what does this look like? We have export functionality. This is used to define what functions of a module can be called by the outside world. It takes a list of functions with their respective arity. The arity of a function is an integer representing how many arguments can be passed to the function. This is critical information because different functions defined within a module can share the same name if and only if they have different arity. Functions add xy and add xyz would thus be considered different and written in the form add2, add3 respectively. So like if you have an add function, like several of them that take two parameters, like some are integers, some are strings, whatever, like you export all of them at once if you say add/2. And you can't subcontrol it any more than that. Exported functions represent a module's interface. It is important to define an interface revealing strictly what is necessary for it to be used and nothing more. To do so lets you fiddle with all the other hidden details of your implementation without breaking code that might depend on your module. All right, so let us also edit this here. We learned module. We should also have export. We pass it in a list. Function 1 slash arity, comma, function 2 slash arity. Okay. So it looks like we're going to export a function called add, and it takes 2 arguments. And now we've got to write the functions add a comma b, and it's going to return a plus b. Okay. This syntax of a function follows the form name args body. So maybe we need to write down at some point here. I guess it's a data type functions, right? Let's just add a comma b. Need to add a plus b return. Okay. Body can be one or more Erlang expressions separated by commas. The function is ended with a period. Note that Erlang doesn't use the return keyword. Return is useless. Instead, the last logical expression of a function is to be executed. Function to be executed will have its value returned to the caller automatically without you having to mention it. So we're just going to return what a plus b is here. And the following function, YS, every tutorial needs a hello world example, even at the 4th chapter, without forgetting to add it to the export attribute. IO format, hello world. Okay. So I didn't add it to the exports. Did they want me to? I'm a little confused. Oh, they do want me to add it. Okay, so we've added hello. What we see from this function is that the comments are single line and only begin with a percent sign. Using percent is purely a question of style. Well, this is a good thing to add up here, right? It's like very early on, just be like comments. Comment is character. Go. The hello zero function also demonstrates how to call functions from a foreign modules inside yours. In this case, IO format is a standard function to output text. A last function will be added to the module using both add and hello. So we have greet and add to. So we'll make this function. I'm guessing what this is. Greet and add to. Uh, maybe it takes in two numbers. Let's guess. And then it's going to call greet. And then it's going to add two. All right, let's see. Greet and add two. Oh, it only adds. It's not saying adding two numbers. It's just saying I'll add two to the number that you give me. There we go. Now we have to add it to our exports. It's probably a little ugly like this, so I need to add a language server for Erlang, whatever it is. This takes in one. Does it have Erlang? Kind of slow. How do you do it like this? Erlang ls not found in path. ELP not found in path. I wonder which one's like a better one to get. Like this was updated when? And then if what's the other one called? ELP? It seems a little bigger. So how about we get Erlang language server 2627. So let's get this one. It's in here. All right, so maybe we have it now. What did it say? How do you look at log? It's missing an Erlang ls config file. That's probably okay, right? It looks like it's doing some formatting now. Let's see here. Oh, it's not doing any formatting. Oh, well, it did that. But it's not any different than what I had before. What if I just had this? Yeah, it's telling me something's wrong, so that's good. Wait. Now why is there a bug here? This closes this. What the fuck? Wait, I'm confused. Why is this not? Oh, probably because this needs to be this, right? And now we're good, right? That's better. I forgot export. I don't know where I lost the hyphen. That was the problem. I was confused. Oh, it's also not happy here. Why is it not happy here? This looks correct, doesn't it? Oh, it's happy now. X. It's not happy with X. Let's see. X is unused, but I have X right here. So, what the fuck are you talking about? Yeah, I was just adding the language server, as you saw, to my Nix sort of setup. Uh, but now, what am I doing wrong? Is this just a language server confused? Because this looks right to me. It thinks that X, it, X isn't used. Oh, they use commas between statements. Holy shit. Did you notice that? That's terrible. Oh, I hate that. This is painful. Can you imagine, like, every statement you have, you gotta put a comma down? It's kind of like saying these are lists. Yeah, neither Nix or Elixir does that. That's really annoying. Hello, Poissonads and the Hyson Vault. Where was I? So we were trying to export stuff here. Where importing a function is not much more than a shortcut for programmers when writing their code. Wait. Okay, so here's what you do when you want to import something. But we didn't have to input anything. This is just saying, like, if you don't want to type in the module name each time, importing a function is not much more than a shortcut for programmers when writing their code. Erlang programmers are often discouraged from using the -import attribute, as some people find it reduces the readability of code. In the case of IO format 2, the function iolib format 2 also exists. Finding which one is used means going to the top of the file to see from which module it was imported. Consequently, leaving the module name in is considered good practice. Right. So if I did an import here and I passed in the module, which is IO, and then I guess I give it the function name format. Format takes in, looks like, one argument, right? Right, there we go. So now that I imported IO, oh crap. Maybe you can't have module and import. Let us comment this out for now. We'll figure this out once we actually get to use it. So this is what our module should look like. Module useless, export this stuff, add hello, yep, I have that. I have my add function, I have my hello function, and I have my greet and add too. We are done with the useless module. You can save the file under this name. The file name should be the module name as defined in the module attribute. So this has to match the file name. Let's put that in our cheat sheet for modules. Note, the name must match the file name. Okay. Uh, Expression sequencing in C. Yeah, it's kind of annoying, I feel like. Um, where were we? And the file name ends in .erl. Before showing how to compile the module and finally trying all of its exciting functions, we will see how to define and use macros. Why are we taking a little pit stop with macros? They are very similar to C's hash define statements, mainly used to define short functions and constants. They are simple expressions represented by text that will be replaced before the code is compiled for the VM. Yeah, I remember this was one of the reasons why uh, Jose Valim made Elixir, because he wanted metaprogramming. I guess Erlang doesn't have like very complicated or sophisticated macros. So it's kind of just like the C version of macros, where it's very like simple token replacement. Such macros are mainly useful to avoid having magic values floating around in your modules. A macro is defined as a module attribute in the form minus defined macro some value. So what do we need here? And is used as question mark macro inside any function defined in the module. A function macro could be written as minus define or hyphen define sub xy x minus y. So it's just gonna like inline substitute whenever it sees sub x comma y with x minus y, and it is used like this question mark sub 20 parentheses 23 comma 47 parentheses, later replaced by 23 minus 7 by the compiler. Some people will use more complex macros, but the basic syntax stays the same. All right, probably this is yeah, I think I pronounced it wrong. I'm so sorry. So is it Jose? Um, Compiling the code. Erlang code is compiled to bytecode in order to be used by the virtual machine. You can call the compiler from many places. Okay, so we just learned the compiler is ERL-C. Not too complicated. Uh, when in the command line, compile colon file name when in the shell or in a module C hyphen parentheses when in the shell. So let us Erlang shell. How did we use the Erlang shell? I think it was like, God damn it. The shell. H. No? No. No. It was Control G, right? Yeah, Control G, I think. No, that was just to abort. Jose. Jose, thank you so much. And I won't remember. I'm terrible. Connect to job, quit Erlang, list all job, kill jobs. I think they just mean this. Oh, okay. So just Earl, they're when they say shell, they mean REPL. Okay, so I was just confused. Let's go back, compiling the code, and now it looks like inside of the shell, the REPL, I can do cd like they're saying, and that actually changes my directory, and then I can compile the file. There we go. Compile OK useless. Interesting. So if I have an error in here, and I do compile useless, yeah, it tells me that hello p is undefined. Did you mean hello 0? Yes, I did. Okay, there we go. And I guess I can be like, this should match okay. That means that it's happy. Um, Wait, do I know you? Have we met? Um, so that was compiling. If you have another message, make sure the file is named correctly, that you are in the right directory and that you made no mistake in your module. Once successfully compile code, you'll notice that a useless beam file was added next to your useless.url in your directory. This is the compiled module. Let's try our first functions ever. All right, so now we have our useless. It's in I tab completed, and I have my add function. Ah, okay, got it. So here's our add. That worked, right? And then useless hello. Okay, it says hello world, perfect. And now we have our useless greet and add. Useless greet and add 2, and we give it a number, right? And it's going to add 2 to that number. So it's going to return 102. Ah, and then it wants us to give it a fake function. So we can also give it something like this, where the arity is 2, and it'll be just like a fake function. Um, yeah, so when we ran this, it returned okay because that's what IO format does, but instead we could just return. I don't know what we could return. I mean, you kind of expect to return the string, right? So you might have like a variable here, like greeting. And you make it hello world. And then you use that greeting in here. But we need to, we didn't learn string interpolation, right? But strings we learned are lists, right? So I should be able to add this to it. Is that what they did for new line? I'm guessing maybe this will work. And now we can return greeting. And we have to remember that these are commas. Let's see if this works. And now I do useless. Yeah, that worked. It still did a new line, and I'm guessing if I got rid of this, that then we would see it all on the same line. Yeah, so here, if I don't put that in there, it prints it, but doesn't have a new line. There we go. Have you heard of Tridectal? Tridectal. It's a Vim control for Firefox, but extremely good. Yeah, I've used stuff like that. You're right. I should do that. So it's a I've had stuff like that, and this is a different machine, so don't have it here, but I do remember really liking it. Good thing to get back to, I think. All right, so we're almost done. We understood all of this. Expression 6 shows an error right. If you're ever wondering, dot beam stands for, oh, I was not wondering, I just thought it was a name. Bogdan Bjorn's Erlang abstract machine, which is the VM itself. Other virtual machines for Erlang exist, but they're not really used anymore and are history. Jam, Joe's abstract machine, inspired by Prolog's WAM, and old Beam, which attempted to compile Erlang to C, then to native code. Benchmarks demonstrate little benefits in this practice, and the concept was given up. There are a whole lot of compilation flags existing to get more control over how a module is compiled. You can get a list of all of them in the Erlang documentation. The most common flags are debug info, out dir dir. Like, okay, so this is going to give you some stuff. Compilation flags. Okay. Debug stuff. Beam files in. So normally it creates. Do I have a beam file? Yes, I have a useless beam file. Um, export all. We'll ignore the export module attribute, instead export everything. It's for lazy people, right? D macro value defines a macro to be used. All right, so to compile our useless module with some flags, we could do something like the following. Here, I see, you pass in the flags like that. Well, I believe that it works, but I do want to put it into my cheat sheet because I will forget. Compiling, you run REPL, then we do C file name. Maybe we put in note node.url at the end of file name. And then you can, what else did we learn? Some flags. We have minus debug info. We have minus outer dir. We have export all. And we have the macro one. And how we run this is we do compile, I guess C, file name, comma, debug info, comma, export all. All right, I think that gives us what we just learned, kind of. You can also be sneaky and define compile flags from within a module or a module attribute. To get the same results as expressions 7 and 8, the following line could be added to the module. Oh wow, okay. Well, that's nasty. That's really nasty. Export all is very convenient for testing stuff in the REPL. Yeah, I agree. Haskell exposes private functions in the REPL by default. That is so useful. Also, like, I'm always fighting with these unit tests where sometimes I want to test my private functions. And in Elixir, it's like I can't, right? Or at least I don't know how to. How do you feel about Erlang as a language to actually use instead of Elixir? Like, is there a place for Erlang outside of history? It seems really cool. What was I thinking about earlier today? I was like, it's like Elixir's doing so much work with the progressive type system that they're adding. It seems really nice to get the benefits of all of those things. And with Erlang, I probably couldn't. So that's one thing. I'm not sure. I'm also guessing that if some of the gen servers, I'm assuming, gen servers are OTP, right? So if I spawn some gen servers from Erlang code, they could talk easily with Elixir gen servers, right? Spawned by Elixir. There's no difference. They're the same protocol. So could play around with that too. More about modules. Before moving on to learning more about writing functions and barely useful snippets of code, there are a few other miscellaneous bits of information that might be useful to you in the future that I'd like to discuss. The first one concerns metadata about modules. I mentioned in the beginning of this chapter that module attributes are metadata describing the module itself. Where can we find this metadata when we don't have an access to the source? This ax and should probably go away. Well, the compiler plays nice with us. When compiling a module, it will pick up most module attributes and store them along with other information in a module info function. So you can see it this way. All right. So if I do C useless, then I can call useless colon. There it is, module info, and it takes no. Aha! Look at that. It looks like this is the SHA of the function. Tells us what we're exporting. I don't know what this VSN thing is, but it looks like it's an attribute. So we have no imported functions. Compile options. So yeah, I guess might as well see it, right? How did we do this? It was like debug info. Yeah. And now when I do useless module. Oh, what happened to it? What happened to you? Didn't want to tab complete anymore. Exports. Debug info. There we go. We see the compile and we have options debug info. That's pretty cool. Where are we? Had you decide to add author to your module, it would have ended up in the same section as VSN. Um, so blah, 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 blah. VSN is automatically generated unique value, differentiating each version of your code, excluding comments. It is used in code hot loading, upgrading an application while it runs without stopping it, and by some tools related to release handling. You can also specify a VSN value yourself if you want. Just add -VSN version number to your module. All right, well, I think it does a better job than me. Another point that would be nice to approach regards General module design. Avoid circular dependencies. A module A should not call a module B that also calls module A. Such dependencies usually end up making code maintenance difficult. In fact, depending on too many modules, even if they are not in a circular dependency, can make maintenance harder. The last thing you want is to wake up in the middle of the night only to find a maniac software engineer or computer scientist trying to gouge your eyes out because of terrible code you have written. The author had a lot of liberty here. There's no one in the place other than me. Stop trying to scare me. For similar reasons, maintenance and fear for your eyes, it is usually considered a good practice to regroup functions that have similar roles close together. This is just like now they're not like I'm so happy they wrote this book. It seems pretty good, but now they're like teaching me programming principles rather than the language and this is just like this is programming now. Like get a programming book if you want that. All right. Well, that's enough for pedantic moralizations. Thank you. How about we explore Erlang a little more? All right. So we're going to stop here because even though it was a short thing, we have already run for an hour and 17 minutes. Time flies. Yeah. So we're going to learn oh, this is like yeah, this is all pretty simple stuff if you know Elixir, it looks like. Then we got guards here. When, same syntax pretty much. A little bit with the commas here. What the if? Okay, so we got some other stuff here. All right, so that should be fast. And then types, let's see what that looks like. Oh, changing types. All right, all of these. You can use that for guards to make sure that what you're getting is a number or whatever. All right. Then we do recursion. What is this? Fibonacci? Uh, or factorial? Length? Yep. Quicksort. Fun. All right. Higher order functions. This should be a fun chapter. I did find out that it is not a lazy evaluated language. It is an eager evaluated language. But what can you expect? Errors and exceptions. This will be good to know, I guess, but like you can program without knowing this kind of stuff, right? Just know some basic stuff like throw. I mean, you should know it obviously, but this is at the point where I might try to program something. Functionally solving. This is just like this is not teaching you anything. uh, about the language now. Now we're just like learning how to. And it's like an example to code data structures. Yeah, we definitely probably want to learn about records, right? I'm guessing records are basically like the def structs in Elixir. Yeah, I know she's there. She's my partner. Thank you. And she knows too that I'm streaming. Ooh, what is this? Key value stores? Yeah, so this is like ETS is used a lot. It's basically a built-in Redis. It's then we get to concurrency. Oh, it's gonna teach us like some concepts first. It's interesting. So here we learn about spawning processes. This is kind of verbose, right? It sleeps for 10 seconds, it prints this stuff out. And here it's receiving messages. And here we're probably talking about like monitoring or linking to a process, which builds towards gen servers and stuff like that. So you know when another process dies or something like that. This helps it like restart. There is a lot of like concepts here, not like, I mean, how do I say this? Like, this book talks a lot about high level coding and design too. So there's a lot more words here. Then we finally get to OTP. Gen server. Start link. So it looks like we're building it ourselves here, kind of. Here's like our kind of main loop here for the server where it's receiving a message, doing something, and then waiting for the next message. So where's the gen server? Oh, here we started, where it must have started teaching us here because I see all the handle call and everything. All right, cool. Oh, looks like maybe they're teaching it here. Oops. Well, this doesn't matter. Finite state machines. All right. Event handlers. Oh, wow. Then we get to supervisors, which supervises these servers and knows how to restart them and all of that. Now we're talking about building an application with OTP. Wow. So this was an example one, and now we talk about them in general. How to release stuff. Oh my god. So, hey there, Kindi. I'm just done streaming now. This is a lot of topics. Like where we did. So this was like chapter 1, 2, 3, 4. So we did 4. So there's, let's count how many more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Whoops. Was that 26? 27, 28. Maybe like, so if we did one a day, this would be like a month. But really, like, a lot of this, I think, is like you can skip. It's not about Erlang so much. Might actually like skip once once we finish with the language, the core language. Yeah, really, like maybe right after this, because concurrency is just gonna be about like how to spawn stuff and all of that. So maybe we can skip all of this stuff and just start using it and programming with it. We'll see. Or maybe we switch to here and just look at like more reference materials on OTP and stuff like that. And really, like OTP and those things change more quickly than the core language. So maybe it's better to switch to here when we get there. All right. Well, that's it. Um, I hope that was semi interesting for you guys. And I will continue on my Erlang quest here. I'm starting to think about what I want to build with it. Either like some kind of game, not like a real game, just like a simple game. Maybe it's text based. Be funny if you played it in REPL. You just call functions. Or maybe this sort of chat server. Games are always so much more fun to program. All right, thanks. I'll see you later.